So we are going to continue our graphing by hand, and we're going to look at the other four functions, tangent, cotangent, secant, and cosecant. And the first one we're going to take a look at is the tangent graph. And the one thing we want to keep in mind is this property right here as we are graphing tangent and thinking of it in terms of sine over cosine, because it does have that denominator. And having a denominator is going to give us perhaps some issues, meaning if cosine is 0, well, now our function is undefined. So if we have a place where it's undefined, what you're going to see, like you do on the side, is we get these things where we have some asymptotes. So we have asymptotes, asymptotes, and that means that we have no values. The other thing that you're going to notice when we're graphing this and thinking back to sine and cosine were always periods of 2 pi. Meaning I could see one full turn of the graph and a value of 2 pi. But if I'm looking at this graph here, noticing that my axis right now, that's 6.28, that's showing you 2 pi. I see more than one turn of my graph. I actually see 2 turns of my graph and a value of 2 pi. So what that's telling me is the period of pi is going to be different from sine and cosine. The period of pi is now going to be just plain old pi. So some important terms that we're going to make a connection with, constants a, b, h, and k. So similar to what we had with our sine and cosine. A, we would have called that in sine and cosine our amplitude. This is just basic vertical stretch and shrink. Okay, the constant b still affects the period. Just keep in mind the period is out of pi this time. H is going to cause still our horizontal shifts. And the K is still going to change vertically, our vertical shifts. So one maybe big change is we're just not going to call it the amplitude. We're just going to go back and think of it as a stretch and a shrink for A. So trying to think of this graph in terms of transformations, y equals negative tangent 2x. If I thought of this as a transformation, that negative sign is telling me we are reflecting over the x-axis. And the 2x, since the 2 is with the x, I know that that's horizontal. And as soon as it's horizontal, I know it's going to be opposite of what I think. So I think it's a horizontal shrink by 1/2. Okay. And then before we graph that, I want to think the period. So the period we know is going to start off with pi, but I'm dividing it by the b value, just like we did with sine and cosine. And our b value is 2. Okay, so the basic period of this is pi over 2. I want to graph 2 periods of the function. So 1 period is pi over 2. 2 periods, so I have to think 2 pi over 2, or just a value of pi. Now, sine and cosine, we would split it up into 4 even parts. The difference with tangent is we're only going to split it up into 2 little parts. So half of pi over 2 is pi over 4, and that's where I stop. I don't have to take half again. But I do have to fill this in. So I have pi over 4, 2 pi over 4, there's 3 pi over 4, and 4 pi over 4. So that's showing me 2 full periods of my tangent graph. Now, when I'm thinking of tangent, I will have some asymptotes. And if I think of this in terms of perhaps the unit circle for a minute, I know at this location, that's my coordinate 0, 1. I know cosine is 0 and sine is 1. And I know that tangent is going to be sine divided by cosine, which at that first location, that first marking I have here at pi over 4, that's going to be undefined. That's going to give me an asymptote. And if I continue on over to here, I could see at negative 1, 0, if I divided that out, that would give me a 0. And if I continued on to my next critical point, 0, negative 1, again, I'm going to get an undefined. And if I go right back to where I started, that's going to give me another 0. Okay, last thing we can think about is that all students take calculus. So in that first section, I know tangent has to be positive. In the second section, tangent has to be negative. but then the third section, it has to be positive. So I want to think this graph is going to be continually increasing. So normal tangent, I'm going to graph this first without the reflection. Normal tangent, if this was the graph without the reflection, thinking increase, increase, and there we go. But that would be a normal tangent graph. That's just plain old no reflection. So now once I have that done, I have to think, well, let's reflect it. If it's reflecting over the x-axis, it still starts at 0, but now this time goes down, starts back up at the top, crosses at the 0, and down, and there we go. So tangent, or y equals negative tangent of 2x, that is that graph. Okay. Cotangent being the reciprocal of tangent, so it's going to have some of the same concepts, some of the same ideas that we did with our tangent graph. We want to think to ourselves, all right, it's still going to have that fractional concept. It's just this time wherever sine is 0, it will be undefined. Okay, so again, if we're thinking that unit circle idea, now sine being 0, that's going to switch from when it was our cosine being 0 for tangent. So that means our asymptotes are going to be different. So the zeros, where we had zeros for our tangent graph, are now actually going to be asymptotes for cotangent. Okay, description for our cotangent graph. So if I were to look at this 3 is a vertical stretch of 3. And notice when we graph it by hand, it's really hard to see that vertical stretch. Not too concerned about that. If I look at the 1/2 x, that's telling me it's a horizontal stretch by 2. And then before we graph it again, let's figure out the period. So the period starts off with pi over b. Our b value is 1/2. So think copy, change, flip. That's going to give me 2 pi. Okay, so if that is a value of 2 pi, and I want 2 periods, so 1 period is 2 pi, 2 periods is 4 pi, and then remember, I only need to take half. So now I have all of my markings. So cotangent graph, remember what we said, it would be opposite. So for tangent, we had an asymptote here. For cotangent, we get a 0. For cotangent, we are going to have an asymptote at 2 pi, a 0, and an asymptote. Okay. Cotangent continually decreases. So when I draw this out, continual decrease, same thing back here, continual decrease, and we have our cotangent graph. Okay, can't really see the 3. That's okay. It would come out more with a verbal communication with saying that vertical stretch of 3. Okay, looking at our secant graph. So we know that secant is the reciprocal of cosine. So you can see on this picture below, I've graphed for you both cosine and secant being the blue graph. And because it's the reciprocal, I like to think to myself, if I can graph cosine, I'm going to find all the critical points I need. But again, with it being a reciprocal, we always have to be careful with having then some asymptotes, because we would have some undefined sections. And so we can see here, wherever cosine is 0, that is going to be an asymptote. If I did a reciprocal of 0, I would get undefined. That's undefined for my secant graph. Okay, anywhere I see a 0 for cosine, I'm seeing asymptotes. Same thing back here if I were to graph on that negative side. So we're going to keep that in mind. The other thing is the maximum points of cosine become your minimum points for secant, and vice versa. The minimum points for cosine become your maximum points for secant. Okay, so transformations. So here we go again. Here's our vertical stretch by 2, horizontal, and we're going to say shrink. Remember, think backwards, 1/3. And now secant, because it's connected to cosine, keep in mind what your period is for cosine. Cosine's period starts off with 2 pi divided by b. So we're back to that 2 pi concept. We're going to take 2 pi and divide it by 3. All right, so when we graph this out, again, we want 2 periods of this. So 1 period is 2 pi over 3. 2 periods is now 4 pi over 3. Since we're back to a sine and cosine concept, we're going to take half again, and now this is what we're going to count by. And there's going to be 4 sections, 4 critical points between for each period. So you have 1 pi over 6, 2 pi over 6, 3 pi over 6, which is pi over 2, 4 pi over 6. Period number 2, we have 5 pi over 6, 6 pi over 6, 7 pi over 6, and 8 pi over 6. Now we do want to think about that amplitude. Normally we would say like 2 would be the amplitude. So 2 is still your amplitude for cosine, so I still need to mark that because remember we're going to start by kind of graphing our cosine graph first. So if this was cosine, I would start up at 2, I would come down, back up, and I would do this again. So here would be my cosine graph, up to here, it would turn back down, what? It would hit down there, back up, and up. Okay. So now keep in mind what we said. The zeros of cosine become asymptotes for secant. So we have an asymptote. Anywhere I see a 0. Asymptotes, asymptotes. And now when you graph, the maximum points of cosine are your minimum of secant. The minimum points of cosine are your maximums. So this black graph that we're graphing out right now, this is going to be your secant graph. Okay, and until you get really comfortable, if you want to draw on that cosine and then do what we just did, that's completely fine. Okay. And the last one we have is cosecant. So cosecant being the reciprocal of sine, similar to what we just did. All right, wherever we have zeros of sine, we have asymptotes for cosecant, sorry. Over here is 0 for sine, asymptote for cosecant. A maximum of sine is the minimum for cosecant, and a minimum value for sine is a maximum of cosecant. Okay, again, it's based off of the sine graph, so again, we're back to a period of 2 pi. You want to keep that in mind. And again, I guess key point, keep in mind why we have those asymptotes. If I have a reciprocal of 0, that means we're throwing 0 in the denominator. Now we're going to get undefined terms. Okay, so if we were to talk transformations, we have a vertical shrink of 1/4. We would have a horizontal stretch of 3/2. And then if I'm thinking period, again, we're starting off again with 2 pi. We divide it by b. b is 2/3. So I want to think copy, change, flip. So if I multiplied that by 3 over 2, that's going to get me 6 pi over 2, which is going to get me a period of 3 pi. Okay, so here we go. We need 2 periods. Keep in mind 3 pi is 1 period, so that means 6 pi is 2 periods. So we start by taking half, and we take half again. And now we're counting by 3 pi over 4, and we need 4 critical points. So 3 pi over 4, 6 pi over 4, 9 pi over 4, 12 pi over 4, 15 pi over 4, 18 pi over 4, which is 9 pi over 2, 21 pi over 4, then 24 pi over 4. Okay, again, we need to put the amplitude, because remember, it's going to be based off of our sine curve. And then maybe start by drawing that sine curve so we get those critical points again. So I can see my maxes and my mins and my zeros. And for now, I'm just going to kind of do a dotted line so I can see my sine curve. And then I'm going to go through and say all of my zeros are my asymptotes. So I have a 0. Don't forget you get a 0 back here. So we got an asymptote there, asymptote here, asymptote here and at the end. And then we can go through and say, okay, maximums of sine are minimum of cosecant. Minimums of sines are maximums of cosecant. That's one period. Here's period number 2. And that's how we graph. So I know there's a lot to do. I know we're going to practice this. Have no fear. Hopefully this help gives you the basics, and hopefully you can just refer back to this if we have to review and try and get some of the basics of graphing these graphs. Okay? Don't forget, like and subscribe. Have a great day, guys.